Hello everyone, I'm Xiaogan. Okay, in this chapter, we'll teach you how to display a dynamic image. First of all, I'll still draw the picture for you. First, we definitely need an interface. That is, let's write it up here. First, we have a dynamic image like a Weibo post, but you have to remember that this one shot is different from this mute shot. Because the mute shot has one more image. This is a single image. Is this a single image? Is this multiple images? The interfaces they use are different. We mainly demonstrate the multiple image one for you. The single image one is relatively simple. That is, you parse this GPG, PNG. Actually, it's all the same. You take this RGBA value and decode it. Then decode its length, width, and height, right? After decoding it, you'll serialize it into our dynamic UX texture. That's all you need. Your texture 2D will do. Then it's the same as using a texture normally. But this is in a runtime scenario, generating a dynamic texture. Of course, here, since we're on this topic, let me mention this. Actually, you can package the WebP into a type of engine asset, encapsulated into a U asset. This one is more complex. It involves editor development, how to define a new type of asset. After defining it, you define the icon it displays. For example, let's call this material. For example, let's call it a picture. Then PICTOR, and it inherits a subclass called UEP. This way, it can be natively supported and used directly in our UE. Of course, this is a very good practice. But I don't recommend you do this. You'll like this. You'd better wait for UE to encapsulate it. You might support it later on, but this depends on the internal exhaust of their iPad. We probably won't support this dynamic output change, because that is in this. In this browser, it's used more often on the web. Okay, then let's talk about the second type. The second type, if there are multiple images, then you will definitely extract the RGB values of the multiple images. RGB. Wait, right here. Change the color underneath this. Yes, you will extract the RGB values of the multiple images. And then there's also our timestamp. Timespace, right? Timespace. After this timespace, and then this flies weight and this H. And then, so what do we do next? Because we know our time is like this. 1 frame, 2 frames, 3 frames, 4 frames, 5 frames, 6 frames. Okay, obviously here, let's say this is 16 milliseconds. This is 32 milliseconds. It is 48 milliseconds. Because we assume that everything we render is very smooth. So if we advance at 16 milliseconds per frame, then it is possible that when we decode this image, it might look like this. It could be 1 millisecond, then 5 milliseconds. Then suddenly, it jumps to 33 milliseconds. Right. So in reality, for example, this point is A, B, C. So actually at the first frame, you should display B. At the second frame, you still display B. Then at the third frame, you display C. So you need to perform a kind of approximation processing like this. That is to avoid it's not matching the game frame rate. So you need to do this kind of mathematical processing equivalent to ours, right? Once this time is reached, we just need to select the frame closest to this time going forward, right? Because this frame is 48 milliseconds. Then it hasn't reached the next frame's time yet. So you choose 33 milliseconds, like this. For example, the next one is D4545 milliseconds. 85 milliseconds, then selecting D, here is fine. This is again simply doing this. This is actually video frames, because video is a continuous sequence of images. So that's how it's done. Actually, the underlying principle, the principle of our underlying interface, looks like this. Let me draw a second diagram for everyone. Okay, as for the second diagram, it mainly returns to our architecture. Fortunately, actually, there is also a render thread here. But we don't need to handle this render thread here, because we only need to do this on our main thread. Modify this uText object, because it is a uObject, and it is an object that needs to be rendered. Then the render thread will automatically update the data inside it. We just need to handle it sometimes. So let's come back to this place. This side is for game story. So this process actually goes like this. For example, 1, 2, 3, 4, 5, 6, 7. Here we write a 0. Here it is 1. R. Okay, at frame 0, we perform this operation. First, we have a Weibo dynamic post P, right? Obviously, now we first need to go to N3. And then we decode here. Wait, why is this part moving? We decode here. So obviously, this place is an image. And then here, we usually call it a decoder. This decoder, after decoding, then it will return to, for example, frame N. I don't know exactly which frame it is, because the decoding time is actually quite long. Frame N, here we assume it is frame N. Then at this point, there will be multiple RGB values and RGBA values, and a set of int type Y and H. And then another set of time and a set of timestamps. Time, type, once we have this. Then next, for example, we take this thing from the N frame, start displaying from the N8 frame. Then the next is N+1. N plus S, N plus. So do you still remember this value from last class? Now at frame N+1. At frame N+1, we take this B1 thing, modify it to our U texture here. Right? We declare a U texture at this frame. We first need to put it in U texture. Then when it renders, this is the render state. After it renders this object into the scene, then this part is actually B1. Then when we are at the B2 path, we sequence this B2 into this U texture. Yes. Then at this point, it is actually B2. In the scene, you see B2. Then we let it loop continuously. After looping to B10, we return to the starting point, B1. Then until we reach a certain frame. For example, after frame N plus M, we don't need it anymore. So we will release this indent. After releasing it, then this part here will be gone. It will be gone, okay? So the entire interaction flow is roughly like this. It should sound pretty fine to everyone. No issues, alright. Next, we will start architecting the code for you.